We will be doing problem 29 of chapter 4. A 40-kilogram wagon is towed up a hill inclined at 18.5 degrees with respect to the horizontal. The tow rope is parallel to the incline and has a tension of 140 newtons. Assume that the wagon starts from rest at the bottom of the hill and neglect friction. How fast is the wagon going after moving 80 meters up the hill?
We're going to start with a free body diagram, as you can see. Okay, so let's find all the components to our incline. Alright, our F of G is 392 newtons. Our force of friction is force of gravity sine theta. So our F of G is 392 sine 18.5 is equal to 124.4 newtons. Our F of A was given to us, so we can just write that as 140 newtons. And our F of N is force of gravity cosine theta, which is equal to 392 cosine 18.5, and that is equal to 37.7 newtons. Alright, now we're going to start solving our problem. So we want to find how fast it was going after moving 80.0 meters up the hill. So to find the acceleration, first we need to look at our x components and take into account the force of gravity in the x direction and the force applied. To get our new force, we're going to subtract the applied force. We're going to subtract the force of friction by the force applied. And that is equal to 15.6 newtons. Now that we have our new force, we can use it to find our acceleration. And we're going to use our original equation, F is equal to ma. Our new force, 15.6 newtons, is equal to the mass of 40 kilograms times acceleration. To find acceleration, just divide 40.0 by 15.6. And our new acceleration is 0.39 meters per second squared. Okay. Now we want to find we want to find how fast it was going at 80.0 meters. So I'll show you this right here. Our acceleration, as we stated before, was 0.39 meters per second squared. Now we're going to list all of our components. We know our initial velocity, it's equal to 0 meters per second. We know our change in direction, which is equal to 80.0 meters. We do not know time. We now know our acceleration, and we do not know our final velocity. So, out of the 4 equations we've been using throughout the semester, we are going to use this equation. The one equation that has all the components except for time. So we don't know our final velocity, so we're just going to keep it as that. Our initial velocity was 0, so I'm not going to even bother placing that.